to understand by putting effort. So yeah, we'll learn many things in this also. You have many examples too. Without any further delay, we will start it, right? Okay, there are many equations you can use here. But yeah, so yeah, let me share my screen to you all people so that you can see my screen. Yes. So force and loss of motion today we are going to do it. I'll just search for a PPT so that you'll understand it clearer than this PDF. Hmm. Yeah, guys, it is opening. Just a second. Yeah, I got it. Yes, so guys, I'm presenting it. So as you can see my screen, today I'm here with a new other chapter. I'm going to like explain you another chapter, which is force and loss of motion, a very, very, very important chapter. I can actually say. And today we are going to do that chapter. So yeah, I don't want to waste my time. Yes. So we are going to do today force and loss of motion, Newton's laws of motion. So first, in this chapter, we are going to learn about force, mass, and what is the difference between those, right? So what is a force? Push or pull. Okay, push or pull required to change an object's motion. A push or pull. The daily life. If I push something or if I pull something, for example, I push you people, then or if I pull you people, then that is considered as a force. So which can cause a displacement, even maybe a magnitude. Okay, so it is vector. That means which have magnitude and direction. Clear? This page is clear, light? What are they saying here? I think you guys are understanding. First thing here, they're talking about force. Force is something which consists of push or a pull. For example, for example, this is something I'm putting force on. This is an object and I'm putting some force on it. Now, what happens? This object starts moving a little bit at least. So it starts moving, and maybe it comes till here. Okay. So this is what here we are. What are we doing here? We are pushing it. Right here we are pushing it. But if you pull it, then the force will be exerted towards this side, right? Then the object starts moving this side. That means this side it starts moving. Okay, this is what force means. Vector means which have a direction. Now, with like it have a direction, right? It have a direction. It even have a magnitude. We'll learn about it. See, you have an example over here. A rocket. From here, it is moving. It is being pushed. Okay, so four forces known in the universe: electromagnetic force, strong nuclear force, gravitational force, and weak nuclear force. Okay, this all we were not required to learn, so we'll skip it. What are the types of forces? Contact force and field force, this is also not required. What is mass? Measurement of how difficult it is to change the object's velocity. Now, to change an object's velocity, for example, this is an object, and to change its velocity, the measurement, the measuring how it is, how much it is difficult to change an object's velocity. Here only we have about inertia, resistance to change in velocity. Okay, laziness. So mass is a measurement of object's inertia. Okay, the change in the object's velocity is called inertia. So the measurement of an object's inertia is mass. So you can see on just a second. So as you can see here, as you can see, a truck came and it actually hit the car. So what happened? This had displacement this side. It had a displacement. It had a displacement this side. Okay. Newton's law. So this is Newton and we have his laws. Newton's background and Newton's laws of motion. First three. First thing is, what is first thing says? An object in motion tend to stays in motion, and an object at rest tend to stay at rest unless acted upon by an unbalanced force. Second one, force is equal to mass times acceleration. For every action, there's an equal and opposite reaction. First law of motion, an object at rest tend to stay at rest, and an object in motion tend to stay in motion unless acted upon by unbalanced force. For example, there's a pen on the table. Okay, as you can see, as you can hear the sound, there's a pen on the table. Now, I saw the pen here. Tomorrow I came and saw the pen. The pen is still over there. The pen is usually in rest, right? It is staying at rest. So if there's nothing applied, if there's not, so first day I came and saw the pen was on the table, and it isn't moving also. And the second day when I came and saw that the pen moved somewhere, the pen moved at the end of the table. Why did this happen? Because there may be some air effect, or maybe someone other than me have done something to it. So what we are saying, until some other force, that means until some unbalanced force is applied by like outside things, then only an object change its rest to motion. Once it is from rest to motion. Okay, so if an object is at rest, it will be at rest, and if an object is at motion, it will be at motion unless there's some force acted on it. This is motion means moving object, rest means taking rest, we say. No, that is what Newton's first law. So what does this actually mean? Basically, an object will keep doing what it was doing unless acted or by an unbalanced force. Yes, an object will keep doing what it was doing. For example, if an object is being at rest, it will be at rest. Okay, unless there's some force acted. If the object was sitting still, it will remain stationary. If it was moving at a constant velocity, it will keep moving. It takes force to change the motion of an object. For example, if there's a bus moving, so you can see here a man a man coming. So the person is going on in a motion. He did not stop at a rest, right? Unless this wall have stopped, unless this wall have stopped, the person would be going only. If there would be no wall over there, the person will be going on, right? He will be in a motion. He came to rest because of a wall, because of those bricks. So ticket, I think you people got due to the unbalanced force. What does this unbalanced force actually mean? If the forces of an object are equal and opposite, they are said to be balanced, and the object experiences no change in motion. If they are not equal and opposite, then the forces are unbalanced. For example, just imagine you have two friends. One friend is like a fat girl, and other friend is a lean girl. I mean, I don't mean like the fat and thin. I'm not comparing here. I'm saying that one is like having more energy, more force can be acted, and one is a lean person. Okay, they if they apply also, there is less force compared to the person who have more energy. Okay, for example, you are at the middle. That person, you're fat. Let's take one and two friend. Okay, one is having more energy, two is having less energy. Now, friend number one is pulling you from the right side, and friend number two is pulling you from the left side. Now, you will obviously go to the person who is number one, because she have more energy, more force compared to the second person. So you'll obviously go there. This type of force is called unbalanced force, because here the force on both sides are not equal. One force is more than other force, right? Other person's force. Now, for example, two of your friends are with equal energy and they're pulling you, so you won't even move. Just try it once, guys. Tug of war. You have might have seen tug of war, right? It's a game, excellent game. We do even play, right? So there's you will have that one rope, and that's it. Some particular group will what do you say? They will pull it, and this side some particular people will pull it. Group of people will pull it. So what happens here? If the energy is more in any one of the group, then their rope of course will go to their team and they will win. But if the force exerted by the both the groups are equal and they're opposite, then they will be balanced. Then the object doesn't even move. There will be no motion. Okay, balanced and unbalanced force. Hope you all got it. Some examples from real life. A soccer ball is sitting at rest. It takes an unbalanced force of a quick change its motion. Tug of war. I said you guys, right? So, for example, these people have more energy. These people have more energy. So, obviously, the rope will go their side. But if there are equal force between this and this people, then obviously it will stay at motion. It will stay at rest. It doesn't even move. Okay. Two teams are playing a tug of war. They both are exerting equal force on the rope in opposite directions. This balance force results in no change of motion. That means it will be in rest. So hope you all are understanding everything, guys, because everything is described in a simpler word so that you'll understand it easily. So next, Newton's first law is also called law of inertia. Why it is called law of inertia? Inertia means the tendency of an object to resist changes in its state of motion. For example, there's a very big rock and you're trying to push it. Even the force is exerted, the rock is not moving, the stone is not moving, right? So this is what inertia applies, because here the tendency of an object, it is staying in a rest position, it's not moving until a lot of force is applied on the rock, then only it will move. First law states that all objects have inertia. The more mass of an object, the more mass an object has, the more inertia it has, and it's harder to change its motion. If I have more mass, more energy, more like energy, then only I will able to push it. So the object will move, and it have more inertia. So the first law of motion states that all objects have inertia. Every object have inertia. Even me, I have an inertia. You have an inertia, but it is compared upon the mass. If there is more mass applied on me to move, then there will be of course more inertia on me, right? So inertia means a tendency. It is harder to change its motion. Simple words. So Newton's first law of motion is also called law of inertia. One examples from real life. A powerful locomotive begins to pull a long line of boxcars that were sitting at rest. Since the boxcars are so massive, they have a great deal of inertia and it takes a larger force to change their motion. Once they are moving, it takes a larger force to stop them. Okay, on your way to school, a bug flies into your windshield. Since the bug is so small, it has very little inertia and exerts a small force on your car. So small that you don't even feel it. Okay. Okay, if how small objects are, how much mass we should apply on it, how much force we should apply on it, dependent upon that, the inertia depends. If there's a less force applied, less inertia. Very big, large force applied, large inertia. If you should move something very, which is of like large object, then you must have a more inertia. Okay. So if objects in motion tend to stay in motion, why don't moving objects keep moving forever? Things don't keep moving forever because they're always an unbalanced food acting upon it. For example, I started going on a road. Okay, I don't want to stop forever in my life. I'm just go, 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 go. I that much petrol I have. Okay, so I want to go wherever I want in that road only. I will go straight. I won't even stop anywhere. So now I keep on going, keep on going. There will be some end point, right? There will be some, a wall or something will be coming aside. Something will be stopping me. Of course, that is unbalanced force. Okay, that's why things don't keep moving forever because there's something unbalanced force applied on it, acting on it. A book sliding across the table slows down and stops because of the force of friction. So force is also a main thing. If you throw a ball upwards, it will eventually slow down and fall because of the force of gravity. Now, if you throw the ball up, it should go up, but it is coming down because of gravity. Okay, the things won't stop. Gravity here is an unbalanced force. So hope you are understanding. In outer space, away from gravity and any sources of friction, a rocket ship launched with a certain speed and direction would keep going in the same direction and at the same speed forever. Okay, here only there's no force, nothing is added, nothing is like keeping on it. So there's no unbalanced force in the space. Okay, outer space. Question: what is the relationship between mass and inertia? Mass is a measure of how much inertia something has. Is inertia a force? No, inertia is a property of matter. Something has inertia. Inertia does not act on something. You just have to write, no, inertia is a property of matter. It's a tendency where object stresses to move. Okay. So what is the before question? What is the relation between mass and inertia? Mass is a measure of how much inertia is something. Mass is a measure how much inertia is. Force of gravity between the sun and its planets holds the planets in orbit around the sun. If that force of gravity suddenly disappears, then what kind of path would they? Each planet would move in a straight line at constant speed. So this we all learn gravitation chapter, centripetal force, and etc. So the Earth moves about 30 kilometer per hour relative to the sun, but when you jump upward, yes. Newton's second law of motion. What does Newton's second law of motion say? First law of motion, what does it state? An object has an equivalent sorry. An object moves in a straight moves like if it is in motion, it will be in motion. If it is in rest, it will be in rest. And it's called law of inertia also. Newton's second law. Force equals mass times acceleration. Force is equals mass times acceleration. That means product of mass into acceleration. The particular object's mass and their acceleration will be equals to force. F equals to ma. Acceleration is a measurement of how quickly an object can change its speed. Okay. See, this is what balance force. Okay. The equal net force is applied. Net force means sum total and direction of all the forces acting on a object. So what is here happening? Here this is a boy who have less force compared to this boy. So the object is moving this side. Here also only two people are this side only. So the object will of course move. But here how what you can see here what you can see the net force is zero because there's equal force. Here the net force is this side. According to the magnitude we can write. This causes acceleration. But this doesn't cause no acceleration. Okay, so let me be back. So yeah, 19 minutes 41 seconds. Yes, So guys, yeah, I hope you all are understanding everything what I'm teaching. So what do you understand from first and second Newton laws? First law says every object which is in rest will be in rest, and every object which is in motion will be in motion. Okay. Second states force is equals to mass times acceleration, that is F equals to ma. Fine. Third, what it states, for equal and opposite forces. What? Law of inertia. 1 minute. So force and laws of motion, balanced and unbalanced force. Balanced force means when an object, there's equal force applied on the both sides and in opposite direction. So and the object will have no acceleration and it will stay, it will be at rest. It's called balanced force. Opposite to is unbalanced force. So going with Newton's law of motion. First law of motion, law of inertia. Second law of motion, derivation of this one. Will they ask us? They will, I guess. Yeah. So we will be back with part two video about the continuous one. So yeah, hope you all will take care of yourself as the situation is not at all good. And yeah, let's fight against this and stop this. I wish fastly this all would be sort out and we all will be back like before, and I want that to happen, and I know that you all also want the same to happen. So yeah, we will wish it to happen soon. And yeah, so don't forget to like, share and subscribe my channel. Let's study class 9. And we are about to complete this chapter and the portion. Yes, we will try our best to complete, and let's try even harder from today so that we could complete all the portion and try to enjoy ourselves and write our examinations well. Okay, guys, so please take care of yourself. Hope you all will stay in home and stay safe. And if you have to go also to school or somewhere, please make sure you're taking everything. I mean every precaution and take caring of yourself. Yes. So, guys, okay then. Thank you. Bye bye. Enjoy your weekend.